Is water is used as an effective coolant. How can water be used as an effective coolant? In the radiators of car or in the generator, we use water for cooling. Why? Because in the heated parts of the machine, around the heated part of the machine, the water pipes are there. Okay, so water in the pipe, what does it do? It extracts the heat from the heated part of the machine. And since the heat capacity of water is very high, so whatever the amount of heat it extract from the heated part of the machine, that it absorbs, but the water temperature will not rise because it has high specific capacity. So it keeps the heated part of the machine cool also, and its own temperature will not increase because it has high specific capacity. Okay, so this is why we use water as an effective coolant. Next, also in cold countries, water is used as a heat reservoir for wine and juice bottles to avoid their freezing. Why? Because so why do you use this water as a heat reservoir? Because the water has very high specific heat capacity. High specific capacity means what? It means that even while increasing the temperature, it needs very high amount of heat. Even while cooling down of water, it has to impart very large amount of heat before it cools down. So during winter, whenever the water has to reduce its temperature, okay, whenever water has to freeze, it has to impart large amount of heat energy. Okay, so this heat energy keeps the bottle warm, okay, for longer period of time. So they do not freeze even though the surrounding temperature is very less than 0 degrees Celsius. Since the water has that heat, okay, and whenever it is cooling down, it imparts that heat to the bottle which is filled with juice and wine, so that they remain warm. Okay, so this is only because the water has the very high specific heat capacity. Similarly, farmers fill their fields with water to protect the crops from frost. Again, so in the cold winter night, what happens? The atmospheric temperature in the cold this one night is very less. It is less than 0 degrees Celsius. So water in the capillaries of that crops, they freeze. Because of that, the veins of that crops burst. Okay. Because once the water freezes, the volume increases, that from 4 to 0 degrees Celsius, the volume of the water increases. Because of that, it bursts. So that will destroy the crops. To avoid this kind of problem, the farmers fill the crops with water, fill the fields with water, so that what happens? Water has very high specific capacity. So whenever the atmospheric temperature decreases, water also starts decreasing temperature. But since it has a very high specific capacity, so to do that, the water has to impart large amount of heat. It has to lose large amount of heat, which it gives to the crops. Okay, which it gives to the crops. Because of that, so it doesn't allow the temperature in the surrounding area of the plants to fall also. Okay, because its own temperature is not decreasing, water on temperature is not decreasing, because it has very high amount of specific capacity. So it takes long period of time to decrease its temperature and finally freeze. So this is how we can save water, save crop from being destroyed. So all plants and animals have a high content of water in their bodies. Why? All the plants and animals have almost 80 to 90% of water in their bodies. Why? Because water has again high specific capacity, which helps them to maintain the temperature in the cold seasons also. Okay, so because obviously if they have high specific capacity, that water has high specific capacity during the cold time also, it doesn't lose heat very fast. Okay, it loses it very slowly. Because of that, it keeps the body at same temperature, okay, in all seasons. Even the during very hot day also, it doesn't increase that much, or in the cold day also, it doesn't decrease that much. It remains constant in all seasons. Some examples of high and low heat capacity. The base of a cooking pan is made thick. We make the base of a cooking pan thick. Why? Because if you make the thick, that means you're increasing the mass. So if mass increases, then heat capacity also increases. It becomes large, due to which what happens? It gets heated very slowly. But whenever it gets heated slowly, it imparts sufficient heat energy at a very slow rate to the food. Okay, so that there is a proper cooking. So once the base is made thicker, what happens? In the base, Heat capacity is lost. Heat capacity is lost means the temperature is increasing very slowly, but it is absorbing large amount of heat. Because of that large amount of heat would impart the heat energy to the food very slowly at a slow rate, and there's a proper cooking taking place. After cooking, it keeps the food warm for a long time also. Next example, the base of an electric press is also made thick and heavy. Why? Again, by doing so, what we are doing, we are increasing the heat capacity of the base, so that heat capacity is increasing means it is hot for longer period of time. It doesn't lose heat very rapidly. Okay, so it remains hot for long duration even if after the current is switched off. So that's the thing. Next, the vessel used for measurement of heat, that is calorimeter, is made of thin sheet of copper. The calorimeter is a vessel actually which we use to measure the amount of heat any substance have. So this vessel is made of copper. Why? Because copper has a very low value of specific capacity, so that if we make this copper vessel very thin also, and it is made of copper also, then what happens, the heat capacity becomes very low, so that the amount of heat it takes from the content means whatever is kept in the vessel, so that is called as content. So amount of heat it receives from that copper vessel receives from the content to attain the temperature of the content is very small, because it has very small heat capacity, the copper. Okay, so that it takes negligible amount of heat from the content to attain the same temperature as content. Okay, so therefore the vessel which is used for the measurement of calorimeter, measurement of the heat of any substance, any content, is made of copper. Okay.